Hi everyone, I welcome you all in the discussion of the quick solutions of All India AIATS Test Series Medical 2020. And we will be dealing with test number 5 code C and D. And here is the first question of the chemistry section, that is question number 46. The most basic oxide among the following is, and we have different options in which sodium oxide is there, magnesium oxide is there, potassium oxide and calcium oxide is there. Among all these, if we consider the increasing nature of basic oxide, if you move left to right along a period of the modern periodic table, then definitely the basic character of oxides decreases. While if I talk about moving down the group in this way, then in that case basic character of oxides increases. It means if I talk about sodium oxide, magnesium oxide, potassium oxide and calcium oxide, in this case sodium oxide is here present as the oxide of group 1 element, while this magnesium oxide is the oxide of group 2 element. Similarly, if I talk about potassium oxide, it's here below sodium. We know that its position. And further, if we talk about calcium oxide, it's here. So in this case, potassium oxide would be most basic. And if you consider along the period, so definitely the basic character is more in potassium oxide. Then definitely this potassium oxide has most basic character. So that's why the oxide which has most basic nature is potassium oxide. That's why I'll choose it as the correct option. 3. Now after this, let's take next question. Question number 47. Among the following, the least soluble sulfate is. Now, solubility of a particular salt depends on two factors mainly. One is hydration enthalpy, that is the amount of energy released during the process of solvation. The second thing is the lattice enthalpy. And for the dissolution, of a salt in water, always the hydration enthalpy should be more as compared to lattice enthalpy. And if we talk about barium ion, it has a larger size. Sulfate ion is there along with this. In this case, lattice energy is quite high as compared to hydration enthalpy. And hydration enthalpy is not sufficient to break the lattice of this salt. It means it is not soluble in water. It means I'll just choose option 4 as the correct option because barium sulfate is here. And this is the least soluble sulfate. Now, after this, next question. Question number 48. Thermal stability of hydrides of alkali metals decreases from lithium hydride to cesium hydride, increases from lithium hydride to cesium hydride, is maximum for potassium hydride, is minimum for potassium hydride. So in this particular case, we are talking about the stability of hydrides of alkali metals. What are the alkali metals? Group 1 elements basically. So what are these hydrides? Lithium hydride, sodium hydride, potassium hydride, rubidium hydride and the cesium hydride. Francium hydride we are not considering, and that depends on the lattice enthalpy. So if we talk about the lattice enthalpy in this case, it decreases. Lattice enthalpy decreases. Why decreases? Because we know that lithium ion has the smallest size and hydride ion is present there. In this case, due to the small size of lithium cation, lattice enthalpy is maximum for lithium hydride while it is minimum for cesium hydride. And in the similar manner, we know that thermal stability that depends on lattice enthalpy. That's directly proportional. It means that as the lattice enthalpy increases, thermal stability increases. So which one is most stable in this case? Definitely in this case, this lithium hydride is the most stable. This is thermally most stable. And on the similar basis, we can say this cesium hydride is thermally least stable. And on that basis, we can simply say that thermal stability of hydrides of alkali metals decreases from lithium hydride to cesium hydride. The first option, that's correct here. And that's why I'll choose this as the correct one. After this, question number 49 we have. During manufacturing of sodium hydroxide in Kastner-Kellner cell, sodium ions discharged at anode, chlorine gas is evolved at cathode, H plus ion get discharged at cathode, and graphite electrode is used as anode. So in this case, we have to choose the correct part. In this case, if we talk about Kastner-Kellner cell, in this case, this cell is used for the manufacturing of sodium hydroxide using brine solution. What is that? That is the aqueous solution of sodium chloride that we are taking here. So in that case, sodium chloride get dissociated into two ions, sodium ion and chloride ion, and the reaction that's taking place at cathode. At cathode, cation moves, and that cation gets reduced by gaining electron. In the presence of mercury, there is the formation of sodium amalgam. We know that. And what happens at anode? At anode, there is the chloride ion, and that chloride ion loses electron. It means at anode, there is the evolution of chlorine gas. That's correct. And if I talk about cathode, at cathode sodium amalgam is formed. So let's check. Sodium ions discharged at anode. This is wrong because sodium ions are there at cathode and they form amalgam with mercury. Further, chlorine gas is evolved at cathode. That's also wrong because this chlorine gas is evolved at anode. H plus ions get discharged at cathode. This statement is also wrong. Now, graphite electrode is used as anode. In this case, yes, graphite electrodes are used as anode. This is the correct statement. So, this answer is correct. Option 4. After this, next question we have. Question number 50. The abnormally smaller size of gallium among its group can be explained by. If we talk about gallium, this is the element of P block and it is belonging to the group 30. Now, what's its electronic configuration? If you look at that, you will identify that its electronic configuration is 3d10, 4s2, 4p1. In this case, you can clearly see that there is the shielding of d electron. The abnormally smaller size of gallium among its group can be explained by the presence of these 3d electrons, and they are creating the poor shielding. So which answer is correct? Here it is given poor shielding of p orbital. That's not true. Poor shielding of d orbital. Yes, it's true. Poor shielding of d and f orbital, it is not possible because electrons are not present in f orbital. Poor shielding of f orbital. Last option is also not true. So only second option is there which is correct. That's why I'm choosing this as the correct option.